This lesson is on factors of whole numbers and multiples of whole numbers. If you see the specific question you're working on below, you can skip directly to the example I've done using the app referenced in the video caption. In this app, you can use it to quickly navigate all of my Math 10 lessons and examples. So prime factorization. This is a pretty fancy term, don't be scared of it. The prime factorization of a number means to break a number down into its prime number factors, hence prime factorization. Factors are whole numbers that divide evenly into another number. A simple example: determine the prime factorization of 6. The factors of 6 are 2 and 3. Its prime factorization is 6 equals 2 times 3. You're done. The 2 and 3 are prime numbers and also factors of 6. Let's look at a more complicated example now and use a factor tree to determine the prime factorization. Example 1. Determine the prime factorization of 2600. This question could also be phrased, write 2600 as a product of its prime factors. We will use what's called a factor tree. So start out with writing the number that you start with, 2600. Now we're going to start forming a tree. 2 times 1300 is 2600. So if it's an even number, you pretty much always want to put your 2 on the left-hand side, and you'll continue breaking it down like that. So let's carry down our 2 now into a third row, and our 1300 is still an even number, so we can break that down into 2 times 650. Carry down your 2's to keep forming our tree. It's going to get larger and larger. 650 can be broken down into 2 times 325. It's still an even number. Now carry down your 2's. Again, 325 though is not an even number, so we need to put a larger number into that, and that will be 5. So 5 times 65 is 325. Feel free to use your calculator to figure the one out for 325 or a number similar to it if it's not directly obvious. Of course, 325, you can see 5 will go into there. 4 won't go into there because it's not an even number. 3 won't go into there because 3 goes into 300 and 3 doesn't go into 25. So that's how I would have figured out 5 goes into there as the next number up from 2. So carry down all of those 2, 2, 2, and the 5. And 65, what do we think about that? Well, that will be 5 times 13. And now we're left with only prime numbers. The prime factorization now we can write of 2600 is 2 times 2 times 2 times 5 times 5 times 13. It's the bottommost row of that tree we just formed. Or, written in exponential form, that is using powers, it is 2 cubed times 5 squared times 13. Your question may ask for it to be written in this form. Note, these base numbers are the prime factors of 2600, in case that is what your specific question is asking for. Example 2a. Find the square root of 225. So the simplest method is, of course, to just use a calculator. If you don't have one or are not allowed to use it on your test, you can use prime factorization. The prime factorization for 225 is 5 times 5 times 3 times 3. Notice there are an equal number of 5's and 3's. Let's group the different values together. So 5 times 3 times 5 times 3. Both of these groups here have the same quantity of 5's and 3's. And we can rewrite the 5 times 3 groups as just a 15. So 15 times 15. there are two equal groups. 5 times 3 is just 15, so 5 times 3 times 5 times 3 is just 15 times 15, and thus the square root of 225 is 15. 15 times 15 is equal to 15 squared is 225. Example 2b, find the cube root of 1728. Again, the simplest method is to use a calculator. If you don't have one, you can use prime factorization. The prime factorization for 1728 is 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. Again, look back at example 1. If you just skip to example 2b or 2a using my app, example 1 will show you how to do this prime factorization using a factor tree. Notice the numbers can't be grouped into two equal groups of numbers, but they can be grouped into three equal groups of numbers. What do I mean by that? You can rewrite what's above there as 2 times 2 times 3 times 2 times 2 times 3 times 2 times 2 times 3. So you can see those three groups of numbers there now are all the same. And 2 times 2 times 3 is 4 times 3, which is just 12. So I can rewrite 1728 as 12 times 12 times 12. Thus, the cube root of 1728 is 12. And notice I made a little mistake there on the second row from the bottom. That says 1727. Of course, that should say 1728. The greatest common factor now. Factors of a number are all of the numbers that can divide into it evenly. For example, what numbers divide evenly into 12? 1, 2, 3, 4, 6, and 12. These are all of the factors of 12. The greatest common factor between two or more given numbers is the largest factor that the numbers have in common. The simplest method and easiest to memorize to find the greatest common factor between a set of numbers is to list all of the factors of each number and then see which is the largest factor that they have in common. Before looking at an example, let's look at a method for quickly listing all the factors of a number. It can take a while to list all factors of larger numbers. Best to do it in an organized manner. List all factors of 144. So let's start by dividing it by 2. It's just an even number, so we'll divide by 2 until we can't anymore. So 144 divided by 2 is 72. Then we have 144 divided by 3 is 48. Divided by 4 is 36. And you can use a calculator quickly to check, does 2 go in, does 3 go in, does 4 go in, etc. So 5 didn't go in the calculator. You can tell it. 5 won't go into there. It's not 145, it's 144. But 6 will go in. 7 won't go in, but 8 will go in. 9 will go in. And 12 will go in. Now, as soon as this number on the right-hand side becomes a prime number or matches the number you just divided by, you're done with finding all factors. So in our case, we divided by 12 and it equaled a 12. So you got the same number that you divided by, you're done finding them all. Because all of the numbers in these two columns shown here are the factors of 144. We can now list the factors of 144 as all of those numbers there. And of course, 1 and 144 are included in this list. Example 3. Determine the greatest common factor of 39 and 72. Step 1. List all factors of 39. 1, 3, 13, 39 are all of the factors of 39. Not too many there. Step 2. List all factors of 72. And there are all of your factors. So if you rewind a little bit the time bar in this lesson, you'll see how to list all the factors of a larger number that has a lot of factors in an organized manner. Look at both lists and see what is the largest number they have in common. 3 is the largest number they have in common, so 3 is the greatest common factor of 39 and 72. Example 4. Determine the greatest common factor of 18, 36, and 54. Step 1. List all factors of 18, and there they are. Step 2. List all factors of 36, and there they are. Step 3. List all factors of 54, and there they are. Look at all lists and see what is the largest number they have in common. 18 is that number, and so 18 is the greatest common factor of 18, 36, and 54. Let's talk about the least common multiple now. Multiples of a number are simply the number multiplied by 1, by 2, by 3, by 4, by 5, etc., etc. For example, the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, etc. The least common multiple between two or more numbers is the lowest multiple that the numbers have in common. That's why we don't have to make these lists too large typically, because it's the lowest common multiple, the least common multiple. A general strategy is to list some of the multiples of each number in a list and then see the lowest multiple that they share. Let's look at an example. Example 5. Determine the least common multiple of 6, 8, and 12. Step 1. List some multiples of 6. So 6, 12, 18, 24, 30. Step 2. List some multiples of 8. So these are the lowest multiples, starting with that number 8. And so we have 16, 24, 32, 40. And then list some multiples of 12. 12, 24, 36, 48. Now look at both lists and see what is the lowest number they have in common. And that number is 24. So the least common multiple of 6, 8, and 12 is 24. Example 6. Determine the least common multiple of 3, 9, and 18. Step 1. List some multiples of 3. So there's some multiples there. Step 2, list some multiples of 9. 9, 18, 27, 36. And then step 3, list some multiples of 18. 18, 36, 54. Look at both lists and see what is the lowest number they have in common. And that number is 18. It can include the number itself in the step 3 there, the last number. 18, of course, is the lowest multiple of 18. It can be itself. So the least common multiple of 3, 9, and 18 is 18.